All right, welcome, and let's go ahead and jump into our STAAR Algebra 1 EOC review. We got 54 questions here. I'd encourage you, please, as I go through these, work the problems, think through them, and do the best you can, then see how I solve it. Your learning is going to increase 2-3 times more if you do it this way as opposed to simply watching this as if you would a movie, because you're just not grappling with it yet. When you do it this way, you'll learn what mistakes you would have made, and you'll easily correct them and never make them again. Your brain will say, no, don't do that again. So sure, watching me work the problem is going to seem like it makes sense. Oh yeah, that's easy, that's simple, but you don't really know until you actually work it. So look, I can't watch you watching a movie. I wish I could hold you accountable that way, but more importantly, I want you to have the integrity as a young man, a young woman, to challenge yourself to do your best here. Let's take this test and be one and done. All right, let's go ahead and get into it. We're going to start with number 1. That's the best place to start, right? So let me pull my writing stuff up. All right, so this one just, most of us get this right, So because we just put this in the calculator, look at the decimal and compare the others. I'm still going to go ahead and do it anyway. Just to make sure. Now, what they want you to do, be honest, is to break this down into perfect squares and then simplify. But that's just not necessary, especially as we get close to the test here. We're only a couple of days away. I really want to get you some strategies that honestly I would use if I were taking it. So first I'm going to put in this equation, square root 1008. And I want to see what that is as a decimal. Yours won't have that, so let me give you, I have a different type of calculator, so it's going to give you a decimal. Then I'm going to go to each one of the others and do the same thing, and I'm waiting to find another decimal that gives me 31.7. So choice A doesn't work. Let's go to B. 7 square root of 7. Choice B doesn't work. And I'm sure you already know the answer. 7, 31. There we go. So that one does work. Obviously, D is not going to work because it's 144 times that same radical. It's just not going to be equal to. So we know it's C. So that's pretty simple. All right, moving on to our next problem. Looks like we have a system of equations here. They're not asking us to solve it. They're simply asking us to set it up. So Anna and Isabel are selling Girl Scout cookies for the troop. Anna sold 12 fewer boxes than twice the number of boxes that Isabel sold. They sold a total of 127 cookies. So when I hear that right there, it makes me pause. Let me change my color. They sold a total of 127. Which system of equation could be used if Anna sold X boxes? This is Anna. And Isabel, so Y. So Anna's going to be X, Isabel's going to be Y. Whatever the case is, I know that together they sold X plus Y. So number of X, number of Anna sold, number of Isabel. So they're going to add up to 127. So this particular equation, this line is totaling up the number of boxes of candy. So the number of boxes here. That's what's being measured in that equation. What else do we have? We know also that Anna sold 12 fewer boxes than twice. Well, that sounds complicated, but if you write it piece by piece, it'll start to come together. Anna equal, because this is what she did, she sold 12 fewer, so I got 12 fewer. So you notice that's minus 12. Something she did was minus 12. So 12 fewer boxes than twice, so I know it's 2 times something, the number of boxes Isabella sold. Well, the number of boxes for Isabel is represented by Y. So this is a type of system that I'm looking for. Even if I just looked at this first one, which ones could I cancel out? Just knowing they add up to 127. Well, going at this looks decent. This looks good. What about this one? G. Now, I know you're thinking, nope, that can't work, but actually it can. Because if you look at x plus y equals 127, if you were to solve for y, which means get our x over here, and now x goes away, now we have y equals 127 minus x. Guess what this is? Y equals 127 minus x. So x plus 7 equals 127 is the same thing as this one. So that's going to have to work. The only one I know for sure is not going to work is h at this point. All right, the other equation I'm looking to verify the correct answer is this one. X equals 2y minus 12. So x equals 2y. So it's not that one. No. X equals 2y minus 12. This is perfect. So I'm definitely going to go with that choice there. And that is it. All right, so again, we're being asked to, actually, this is not again, this is not a system. Fast food franchise owner has 2 locations. The polynomials represent the cost of each location, A and B. Which expression represents the total cost? So this is the cost for A, cost for B, total cost. You just add up 2 things. Now, back in elementary, whenever you got a problem like this, it would simply add 2 numbers, 3 plus 2, or 25 plus 82, something like that. But now we're adding these things that are an expression with variables and such. So we're still going to do the same thing. We're going to add this top one with the bottom one, but I can add my like terms first. So we add the coefficients in front. What is 4 plus 1/4? Well, that's just 4 and 1/4. But I don't see a 4 1/4 here. So what's going on? Well, they don't have it in mixed number form. They have it in improper fractions. So the numerator is bigger than the denominator. How did they get that? Well, 4 times 4 is 16 plus 1 is 17. 17 over 4, if you divide it, it's still going to give you 4 1/4. You could do that work if you wanted to find out. 4 goes into here 4 times. That's 16. Leave me with 1. So I got 4 and 1/4. So that's how they got that. Let's make this bigger. All right, so which expression is going to work here? So I know I got 17/4, but that doesn't help me at all, does it? So they assume we know how to do that part. But now let's combine, we did that, let's combine our c's. We got -2/3 and a -5/2. I don't know if your calculator will add fractions without turning it into a decimal. So I wish I had your calculator up here, but I'm going to try it. So I need to add -2/3 and -5 over 2. So -2 thirds plus 5 over 2. So what would happen if I put, actually I shouldn't say plus, right? It should be minus. Minus 5 over 2, because both of these have a negative sign. So it's like -2/3 plus a -5/2 or -5/2. They're both the same thing. So that gives me, yay, mine does it. But at the minimum, you could find out what that's going to be and look at which one is equivalent. So it becomes easy at this point because this is the only one that has a -19 over 6 with it. As a decimal, you will get that. And this becomes easy too because -2/3 is not equal to 3. 19 divided by 6 is going to give you a 3. These won't even get close to that. So I'm done. Once I saw that, let's check. Oh my, what did I do wrong? Oh, you know what I did? Oh my gosh, I fell for it. And I did this right the first time. Do you see what I did wrong? Let me go back here because that's upsetting. So I did not combine like terms. Just because these guys are on top of each other, I assumed they were like terms, but this has a C and this one doesn't. I'm so glad I did that actually, because I need you to pay attention to that. So I know that -2/3 C has no other thing to combine to, so that's going to stay there. And actually, I know it's not that answer. Well, we know that now. So I actually need to combine my 5 and -5/2 is what I need to be combining. So I'm going to say 5 minus 5 over 2. As soon as my calculator catches up with what I'm doing. Negative 5 over 2, that gives me 5 over 2, which makes sense. 5, I just realized that 5 minus 5 over 2. 5 over 2 is just $2.50 or $2.50. So 5 minus 250 is 250. So that's what I'm going to get there for the end. And it's going to be a positive 5 over 2. So there you go. All right, what's the y-intercept? You guys should be killing that one. How easy is that? Y-intercept is right here. Crosses the y-axis, so that's a 1, 2, 3, 4, 5. Nothing else really to say on that. There you go, 5. The line graph on the grid represents the first 2 equations, first of 2. So you know there's 2 here, but this is the first of 2. If the graph of the second equation in the system passes through these 2 points, which statement is true? We have only a solution here, a solution here, no solution at all, or infinite number of solutions. So you would be tempted to first just plot these 2 points, right? -6 and 32, but it's not up there. Or you could plot 4, 8, -18, but that one's right on the line. I wonder what the other one would be. So let's find the slope. You know, better yet, I'm going to show us. Just if I put these, let's find the equation of this line. Let's get some points. So that looks like this is at a 2. My y-intercept is at 2. Y equals. I know my y-intercept's at 2, and I know it's a negative slope. Some negative slope. This is a +2. Here's an x. What's the number here for my slope? This is, I bet it's a halfway mark, so I'm going to assume that. So we're going from 2 down to -8. So I went from 2 down to -8. How much did we go down? So from 2 to -8, that's 8 plus another 2 more, that's 10. So we're going down 10. And we went over from 0 to 2. So it looks like it's -5. So my slope is -5. All right, let's look at what these 2 points are going to give me. What kind of slope and equation they're going to give me in our calculator. And I like to open up a new document now just to clear out everything. And let's do spreadsheet. Put this all in there. We only got 2 points, so it should go by quick. -6 and 32. And then 4 and -18. I'm going to look at it from here. Press menu, data. Do a quick graph. There's my y there. There's my x. I know this is going to make a line. Let's see what the equation looks like. Regression, show linear, and it's -5x plus 2. That looks really familiar, doesn't it? Because it's the same one we got for this line that's already here. So this line is exactly the same line, which means how many places do they cross and touch? They're going to touch infinitely. So they should have infinite number of solutions there. And there you go. What's the domain of this? That's easy. It's a quadratic, I can see. And I can see it's going down. So if I were to just sketch a quick drawing, I know it's like that. And it's going to go forever in the x directions. So bam, there it is. Now I'm going to go ahead and graph it because you may not see it that clearly when you do it. And I want you to have a good feel for this, how to get through this, even if you maybe don't understand it the way I just explained it there, as far as how quickly I got it. So let's write this the way they wrote it. -5 plus 6x minus x squared. So you can just look at it there. And if you were really curious, you could trace it and look at how far the x values are going to go. So if I did trace, then I could just trace it, and I can see my x's right here, -3, -4, -6. It just goes on forever. Now, it didn't look like it, right? So if we went back to the top, it looked like it's kind of going to line up and go straight up and down, but that's what I'm telling you about quadratics. The x's are going to keep going that direction, and you can test it yourself to see that. All right, so let's look at our answer as we suspected. Apollo books include a 252-page novel and 5 paperback books. Each paperback book has exactly 100 pages. If X paperback books are added to the pile of books, the number of total pages in the pile can be represented by this function. What's the range? So all that talking that they just did didn't mean anything because they gave it to us as a function. What they're saying is that 252 is the number of pages that we're starting with, and then they're adding on a book at a time, which is about 100 pages each. So what are the possible ranges here? You could think about this one if you understood what range was. So my domain is going to be here. So let's say my domain was 0, which means they didn't put on any books. What's my range going to be? Here's my range, f of x, my y value. They put a 0 here. 100 times 0 is 0, and I got 252 left. So I know that's going to be my first y value, my range. It's not going to be A or B. Well, what if I put 1 there? No, it's not here. What if I put a 1 here? Well, that's 100 times 1 plus 252, so that'd be 352. And that's the only one like that. So I know that's my answer. But if you couldn't see it so clearly, what could you have done? Yes, you sent it. Just put in the calculator. So they already have an f of x, so I'm going to leave it that way. I'm just going to change the one we already have. So I'm going to write this in 100x plus 252. And I don't really care about that line looking like this. I'm curious about the table. And I can see what's going on each time, right? So at 0 is 252, 1, 352, 2, 452. So here's all my range values right here in a y, f of x, which is a y column. And that's what they wanted. So there you go. There's all your numbers that we're looking at right there on C. So that better be right. And there you go. Area of a rectangle is that. So let's... Area of a rectangle is length times width. If the length of the rectangle is that, which is the expression of the width. So we want to find width. How do we do that? Well, hopefully you're thinking I got to get rid of this L. If I divide both sides by L, that will give me the width. Width is equal to the area divided by length. So here's my area. And here's my length. And now let's go to work. Let's do each part that's alike first. 32 divided by 8 should be 4. So I know it can be that one or that one. So we're done with that part. And then I got an x. Did I write this right? No, that's supposed to be a y. That makes a big difference. All right, so we have x and x on top. What do you do when you're dividing the exponents? Well, we know we can subtract our exponents, and you can look on your formula sheet to get that because it shows you how to do it. So 9 minus 7 is 2, so I end up with 4x squared. And then what do we have here? 9 minus 9 is just 0. So y to the 0, anything to the 0 is 1. So this is all I have left. And that's it. All right, number 9. What's the value of p of 7? So in place of p of x, we're putting a -7, and that's just that simple. So I could just do that by hand if I wanted to. Squared, this whole thing squared, plus 8 minus 9. So -7 squared is 49, plus 8. Add these two together, that gives me -4 times 57 minus 9. And now I do want to use my calculator just because there's no need to do it by hand. Not that I can't, but what's the point? I can just calculate this here for more accuracy. -5 times 57 All right, equals minus, I wrote looks like a 9. Did I mean 9? Yeah, minus 9. All right, so why am I not getting the answer? What did I do wrong? Oh, yeah. Negative, I wrote my negative 4 times 5 instead of 57. Negative 4 should be negative, that's not negative, negative 4 times 57 minus 5. And I don't see my answer up here, so I'm doing something wrong. What did I do wrong? 49, 57, 49, negative 7, that's 49. That's plus 8 is 57. Negative 4 times 57. And then subtract, I subtracted 5. See these little things, if you write sloppy, it should be a 9, not a 5. So I should have did negative 288 minus 9. No. Alright, so I just paused it and came back because I had to rework this. Why is this giving me two different answers? So look at this. I put negative 288. All these little mistakes. So it should have been negative 228. Not 288 minus 9. And there's my correct answer there. Alright, happy to move on from that. So just watch out for those little things. Now, I didn't have to go through all that. You just want to put in your calculator. Then that's exactly why I said just use the calculator first. There's no reason to miss that type of problem just because we don't put in the calculator. So like if I could have did this and been done with it, takes a little bit more time, of course, but what's the big deal? Who's going anywhere for 4 hours anyway? So negative 7 squared plus 8 close parentheses minus 9. Yeah, so why I just didn't do that? Let's see what it gives me. Hey, negative 37. All right, moving on. Which system of equations best represents this graph? One easy way to do this problem, right, is just to put all these into your calculator in the relation, right? So you could just go here, delete this, and put these two equations in, see if it gives you that, put these two, see if it gives you that, and keep going through all those. You could do that. I don't want to do that because it just takes time, so I'm thinking of a faster way, but I might have to. X and Y, yeah, looks like I might have to. Just check it. Now, here's the way I could do it. I think they want you to do it. Is find some good points. Like this right here is obviously a good point. This is at 1, 2, 3, 4, 5, 6, 7, 8. So that's at negative 8, 1, 2, 3. Negative 8, 3. That's one good point that we do have for sure. Now, since you know that point exists, you could just put that point in for x and y and see if you get negative 35, and for x and y, see if you get negative 9. Whichever it works for both equations, you know the answer is right. Again, that takes a lot of time, but that's one surefire way to get your right answer. You could find the equation of each line and then put it in standard form. So let's see. I know there's a point here. So this is, I can find the equation of this line. There's a 1, we're at 3, 4, 5, 6, 7. And so this is at a y value of 7. And we went over 1, so that's at a negative 7. So I can put that on my calculator and figure out what that is. I don't want to do each one of them. just to save you time. So let me skip to how it looks on the calculator when you do it right. All right, so I put the F in, so we see that that's the right answer. But if you were to put every one of them in, you could look and see which one looks like that and where it's crossing. I can count this one: 1, 2, 3, 4, 5, 6, 7, 8. So that's -8 and 3. And you can analyze it and see that it does indeed cross right there at -8, 3. And it looks like the same line anyway. So that should be pretty easy. Just plug those in and compare. All right, how many seats are there in each row of the auditorium if there's a total of 1325 seats? So the total number of seats in the auditorium is modeled by, so the total number of seats is modeled by this equation. When they say that, they're telling you that this f of x, this y value, represents my total number of seats, where x is going to represent the number of seats in each row. So x is my number of seats in every row. So what are we looking for? How many seats are there in each row? So we're looking for x when there's 1325 seats. So the hardest part in our questions oftentimes is understanding what in the world are they asking me. So we're looking for x value when the y is 1325. So let me write that out so you can see it. 2x squared plus 3x. So what does x need to be to get 1325? You could put this in your calculator just like this as a graph, and it'll give you a straight line up and down wherever the number is. Or better yet, just try using InSolve, see if that works. Now I'm curious, I haven't tried this way, what it would look like if I factored out an x from both of these. Be 2x plus 3. Does that help me at all? Doesn't look, oh, well, it could if I would just put this, actually, maybe I should do that. If I would have just changed this into a quadratic that equals 0 by subtracting 1325 on both sides, 25, then it'd be 0 equals 2x squared plus 3x minus 1325, 1325. And I'll put that in my graph and look for where it crosses the x-axis because I want y to equal 0. But you could also put it in like this, you know, just the same way you wrote it. Just replace that 13. One way you could do it is use InSolve. So let's look at that. So we'll use InSolve and just put it in just the way it is. So we do 1325 is equal to 2x squared plus 3x. And we want to know where x is, what's the value of x. I feel like I'm missing the parentheses, but we'll look at it and see. Alright, so it can either be at -53/2 or 25, and you're not going to have a negative number of seats. So 25 is going to work here. Now your calculator is not going to give you two answers more than likely. It's probably just going to give you one positive answer, which is perfect because that's what we want. Or you could have graphed this whole thing. If you would have put this in our graph, actually let me see if I can copy this. So if I put this in my graph, deleting that, goodbye, and I put this in just the way I had it, right there. Let's see if we can fit the graph, even though we're using relation, because a lot of times it may not let us do a lot of things. So we're going to fit, yeah, we can see it. So that's where it crosses the zeros right there. We can analyze, and I'm not sure if yours will do it. Let's say what graph you're talking about. I'm talking about this one. Oh, it doesn't see the graph. See, when you put in relation, it doesn't see a function. Now we can see that it's going to be right there. It looks like pretty close to 30.15. And you could trace it if you really needed to. It's a lot of ways you can get your answer if you create it. So right there, you see it, 25 equals 0. So right here. I just started pointing to the screen with my finger, and you didn't see that. All right, so that's it. So that's how we get our answer. There's a few ways you could have done that, and hopefully that was helpful. And here we're asked about an asymptote, and asymptote is an imaginary line that the graph, which is right here, is getting really close to but not touching. So that's obviously going to be M. Now it looks like it's going to touch because it's so close, but it's actually not touching. It can be P because this line right here is going to eventually cross this line way up here somewhere. Q obviously crosses it, but the one that a lot of people get confused is picking N because they say, oh, it's not going to cross N. But the problem is nor is it getting close to N. Nowhere close. It's never going to pass the line of M. It's going to get really close to it. But it can't be N because it's not even close to there. So it needs to be approaching arbitrarily close. That means so close that it might as well be touching. So we're going to go with choice F right there, line M. All right, so for this one, we got a hot air balloon that is at an altitude of 2250, and it looks like it's descending, which means going down 22 feet per minute. So what I think of when I see that is I think of what it looks like on a graph. So if I were to draw a graph, I think of a hot air balloon up here at 2250, and it might even help to draw a picture, right? So I don't know. Here's a picture. It's my hot air balloon. Some decorations. You can draw some people in there. Okay, don't get too carried away. But you get the idea, starting at 2250, and it's descending, which means going down at a certain rate, which is 2250. We don't care about what's down here because that's below the ground. We don't care about what's over here because that's negative time, -1, -2 minutes. These don't mean anything to us, nor does this. But quadrant 1 has all our data in it. So getting back to what we're talking about, which equation goes with this line? Well, I know that the y-intercept, first of all, y equals mx plus b. At this point, I'm hoping you remember that b stands for beginning. Where we begin at was 2250. This is our y-intercept, so I know I'm going to have 2250 here as a y-intercept and 2250 here as a y-intercept. This y-intercept can be found by multiplying these two, but we know it's not going to give us 2250, so that's not right. And we have a -2250, and this is underground, so I know that can't be right because we're not starting at -2250. So goodbye D and goodbye C. I love it, right? So most answer choice is going to go down to at least 2. Only 2 remaining. So both of these have a y-intercept of 2250. Now notice that they're in different spots. It does not have to be at the end. So don't get used to that. Just the number being by itself makes it a y-intercept if it's not next to this x. So it's a positive 2250. Now we're looking at our rate. We know that we're descending, so we're looking for a slope that's going down at a rate of 2250. And it looks like B is that choice. Let's check and see if B is indeed that choice. Yay, it is! So hopefully that's what you got. If not, now you get it. All right, next question. What is a positive solution to the equation, blah, 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 blah. So let's make sure you understand what they're asking. First of all, they're saying, what's a positive solution? What's the answer? Basically, here's another way they're asking. What does x need to be to get 0? What does these x's have to be to get a 0? What's the solution here? And if you see a square, you should know already that's going to give us some kind of parabola. If you see a negative sign, it's going to be opening down. And in essence, what they're asking is, when is this going to equal 0? When is the y value going to be 0? What does the x value have to be to get a y value of 0? So in other words, they're asking for the zeros, the roots, the solutions, the x-intercepts, all of the same thing. So to find that, if you understand what I just said, finding this becomes easy because you're going to think, oh, it's simple. I'm either going to put this in my graph and look for where it crosses the x-axis, or I'm going to put it in solve. So I'm going to put this in my graph because that's the more professional way to do it and to really see what's going on. So I'm going to add a graph here, and let's do negative x squared minus x plus 20. Minus x plus 20. And just a little side note here. When it said minus, I have to push the minus sign. If I push the negative sign, it's going to think I'm doing a negative number and multiply. Let's see. Let me go back and do that again. So if I say negative x plus 20, so I think it's going to treat it differently here. It's going to think I'm trying to multiply. Watch. Oh, it didn't do it. Good. Okay, so it treated just like a minus sign. Oh, let me make sure. Let me change it to minus. Yeah, it treated just like a minus sign. So great. So now we see our answer, right? Or do you? I had a lot of students get to this point just because they know they should use the calculator to do something, but not really understanding what we're looking for. So hopefully you're seeing the answer is where your y value is 0. Where your y value is 0 at any x-intercept. So it's here and here. And you can just count 1, 2, 3, 4 and see that I have a positive 4. So we want the positive solution. If we wanted both, it would be 1, 2, 3, 4, 5. So negative 5 and 4. But in this case, we just want what's positive. You could actually find that number by allowing a calculator to do it for you too. So if you just went to menu, analyze graph, look for the 0, click on both sides of that number, it'll tell you what that point is. All right, so there you go. Let's erase that. No, I don't want to save. And I'm starting to do that more often too because it just makes it easier from not having stuff left over from the last problem. Okay, bam, 4. Number 15, a student graphed f of x equals x and graphed 1/3 f of x on the same coordinate grid. Which statement describes how the graphs of f and g are related? All right, so first, let's understand what in the world are they saying. Okay, they got all this g of x and f of x stuff with a 1/3 in front of f of x. So here's what they're saying. F of x equals x is the same thing as just y equals x. Okay, actually I'm gonna go ahead and graph that while I'm talking about it. Alright, so that's just y equals x. So I can just put an x here, and it's the same thing as that graph. There you go. Now they want to know, what if you had another graph, we're going to call that one g of x, where it's 1/3 f of x, which means 1/3 of whatever this was. So in other words, I could write this f of x equals 1/3 of whatever's over here. And since only x is here, it's just going to be 1/3 x. So that's it. They're saying 1/3 of f of x, 1/3 of this function. So now if I go back to my calculator and graph this, I just want to pull up another one. So if I just pull up one, I'll do a fraction sign to make it easy for you guys to understand. 1/3 x, and press enter. Bam, there it is. Easy to see. Now let's look at the question. See, I didn't even look at the questions yet, but now it's going to be pretty easy. Hopefully I did that right. Let's find out. The graph of f is shifted to the left 3 units. No, there wasn't any shifting. If it was shifted, it would have stayed the same slope and just moved over a little bit. So there was no shifting. Now we do have a change in steepness. It says the graph of f is less steep. Well, here's the graph of f right here in blue, and here's the graph of g in red. So graph of f is definitely not less steep, it's more steep. The graph, so no, it's not less steep. The graph of f is shifted. No, it's not shifted. And yes, it is steeper. The graph of f is steeper. So let's check to see that one. See, I didn't even check the answers yet, so I'm just as surprised as you are. We'll see what we get. I'm just doing this off the cuff. Yeah, that's what I thought. Again, this doesn't require a lot of math, but it does require that you understand what in the world they're saying right here. 1/3 needs to go in front of this whole function. So this whole 1/3, if it was x squared, or x plus 2, it needs to go in front of 1/3 times x plus 2. Whatever's in front of there needs to, whatever's there, 1/3 needs to go in front of it. All right, next question. Which equation best represents the axis of symmetry? Axis of symmetry. Symmetry is going to be something that's split in half, and you're going to find the symmetry always at the vertex, the highest point. So it's right there. Now, just because you can't, let's see if I get a different line here. I didn't know I could type. I can type. Oh yeah. Okay. We'll do that maybe another time. But here's your line of symmetry. Bam. Right there. So I had a question when someone was doing this. They said it can't be symmetric because it's not even going all the way down. But you see this arrow means it's going to go all the way down. Just because it's cut off on the screen doesn't mean it stops. So it's going to go all the way down. So don't think that if I did that, it's not symmetrical anymore. This graph, this function, is going to go on forever. We, with our human eyes and the space on our paper, can't see the whole thing. So it doesn't matter where we cut it off. We're interested in what's happening throughout the whole thing. So the next problem is, or the next challenge is, naming that line. Well, every point of this line has something in common. This is, let's look at the points here. This is -3, 1, -3, 2, -3, 3, -3, 4, -3, 5, -3, 6, -3, 7, -3, -1, -3, -2, -3, I think you get the point. No pun intended. All our values for x are -3. No matter what the y value is, we always have an x equal to -3. That's why I know that it's going to be x equals -3. And one easy way for me to remember is this line is crossing through the x, so it's going to be x equals whatever that number is. All right, what's the answer? Survey says 16 for 16. I haven't gotten them wrong yet. All right, a student used f of x equals this to show the balance in a savings account will increase over time. What does this 6.5 mean? All right, that should be easy. So if you remember our exponential, because you see the x in the exponent, so that's an exponential growth or decay. And it's a growing problem because we got 1 plus some number. If it was less than 1, it'd be decaying. But what does the 650 mean? 650 means, remember that we have a, b to the x. So this a is going to mean our initial. This is where we're starting. It's kind of like our Y-intercept. Well, it is our Y-intercept, actually. So it's where we're going to start out. There you go. That's the starting balance. Yep, sounds good. It's not the interest. It's not the interest the savings gets. It's not the number of years. Number of years is x. The interest is going to be the 0.25 times 6. Anyhow, it doesn't matter. It's the starting balance. That's what you need to know there. Okay. All right, which order pair best represents the location of the Y-intercept? Man, this is so easy. 1, 2, 3, 4, 5. So your only challenge here is, 1, knowing what a Y-intercept is, knowing that this is the graph that crosses the y-axis here. That's the only challenge. Oh, I'm sorry, not the only challenge. The second challenge is, how do you write it? Because if you can cross out these two, because we know it's not the x-intercept, so we're not thinking about 3 over 2. This is not it. But what would challenge someone is what? Which one goes first? I do still see students make that mistake. Remember that it goes x, y. X goes first, just like in the alphabet. We start at origin and we count how many we go over in our x. Well, since we are not moving left or right in our x, we're going to put 0. And then we move up 5, so that means this is 5. So that's how you're going to remember which one to count. So we're going to go with J. J. All right, what is the equation in slope-intercept form of the line that passes through the points? Slope-intercept. Oh, you know what? I could be using my calculator more, but I don't really have to on those problems. What's the equation of the line slope-intercept form that pass through here. You know the first thing I'm thinking about doing, right? So yeah, you could do by hand. You can find the slope and then y-intercept. But my goodness, if I'm allowed to use the calculator, I'm going to do just that. I'm going to open up a new file. I'm not going to save. And then I'm going to go to my list in spreadsheets. And I'm just going to put these 2 points in and let the calculator find what that is for me. That's what I'm going to do. Not that I can't do it, mind you. But hey, why not? If the calculator is a lot more consistently accurate than I am, let's go with that. So there you go. There's my first point. 10, negative 57. Negative 57. And notice I didn't leave it on negative 57. Like, you don't want to leave that point right here, or it won't tally. So I just need to move off there. All right, so now you could go back to your home screen and do a list, but I've learned to just analyze it here. Just press menu again, look at data, and do a quick graph. And we end up getting the same kind of look here. So click here for my Y, down here for my X, and then I'm going to analyze the graph with menu, regression, and I'm looking for a line and slope intercept form, and here we go. Oh, this is just too easy. Who came up with this test? Who fails this thing? Have you not been in my class? All right, so there's your answer right there. So we just need to convert these fractions to decimal form to figure out which one it is. But already we can cross a couple of them out because the y-intercepts are off. So it's -6, which is a whole number in front. So we know this can't give it to us. That's a decimal. So this has to be it. 32 divided by 5 is about 6. Or we'll see. Bam! There it is. It's beautiful. There's so many ways to solve that, by the way. You could put in x in place of x here. You could have inputted x here and then y here to see if it's really equal, and then if it's true, do that for both of them. And if that's true, then you found it. But anyhow, this is the easier way if you ask me. Transformations. All right, let's remember our hippopotamus here on the transformations. And if you don't remember, look, just put in the calculator. Just put that and this in the calculator to see which one it is. And that's what I'm going to do now, because I know a lot of you guys watching this don't remember the transformations. So I'm just going to do that. Let's go to our graph. And I'm just going to put these both in. So it's asking, the graph of x squared is transformed to f of x plus 2. Which graph best represents f and h? So again, f of x plus 2 mean in place of your x, so they put x plus 2 there, and you're still going to square the x. So now we're going to put both graphs in, x squared and x plus 2. This is going to end up being x plus 2 squared, because we're still going to square whatever. They're saying in here, replace, instead of x, replace it with x plus 2 and continue doing whatever you were doing, which means it was already square, so go ahead and put the square up there. So that's what we're going to do. We're going to continue doing just that. So this is x. I'm sorry, x squared. X squared. And then we have parentheses x plus 2. Oh my, what am I doing? Okay, there we go. Nope, don't need all those parentheses. All right, squared, there we go. So let's see what happens. Bam, there it is. So easy to do. So if you were able to understand how this looks when you put it in the equation, it's easy to see now that my original, which is f of x, which is the dotted line. So keep that in mind. F of x should be the dotted line. That's good. And my h moves to the left. So no, that moves to the right. That moves up. This moves to the left. This moves down. h is what I want there. And if you do remember the rules, you remember that the hippopotamus goes in parentheses. That's the x plus h. It goes the opposite way, 2 units. But in case you didn't, there you go too. You now know how to do it. Which order pair is in the solution set? First thing I want to do is graph this one. I like to graph this by hand because it's so much easier. But since we again have the calculator, why not use that? I'm going to open up a new document and I'm going to graph it just the way it says so. So this time I'm going to delete that equal sign to get y is less than -1/5. Now I do want to make a note not to use relation if it's already in f of x or y form. The only reason I have to do this now because it's asking for inequality. And I say that because you're limited in the other skills you can use on a calculator. So if you use relation, you can't do a table, you can't analyze the graph, you can't look for an intersection, you can't look for a zero. There's stuff like that you can't do. Now it's still great to use if you need it, but don't use it for everything. Like if it's f of x or you can get it to y equals, try to use that because you just get more options. Alright, so y 5 x plus 6. Bam! Alright, so when here's again, some of us having a problem with the question, a solution set. That sounds really weird, really hard. What is a solution set? We don't talk like that. Well, this whole blue area is a solution set. That means these are all the possible answers that will make this true. These are all the points in here that will make this true. So this point, this x and y value, if you put that x and y value in here, this would be true. The y value here would be less than whatever that equals over here. So that's the point that they're asking. So now we're trying to test all these points to see if it's in that solution. So let's look at it. 0, 6 is 0, 6, 1, 2, 3, 4, 5, 6. 0, 6 is on the line. What do we do with that one? Well, first of all, I just realized they didn't make a dotted line. This should have been a dotted line because it's not equal to. And some programs do that, but this one didn't. I think yours does. If it's on a line and it's not equal to, you cannot include that one. I'm sorry, buddy. 1, 2, 3, 4, 5, and up 8. Let's pass here. Nope. -12 and -5. That's definitely within the solution set. All that space down there is blue. Look at that. Oh, this area is here. -12. Yep, all that stuff. So let's go back to here. What about 10, 7? 10, 7. Well, let me go 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 is going to be up here. Nope, that can't be it. And that's it. Another way you can do this, but I don't want to show it just for the sake of time, is you could plug you can go to your just calculator screen and plug in each point, plug in the y, let's see the x, plug this in for your x and plug this in for your y and write it out just like this. So you'll write -5, just type the whole thing in your calculator. -5, here I am doing it anyway, it looks like, is less than, and you just keep typing just like everything you had, -1/5 times, we just put a parentheses there just like they have, -12, close parentheses, plus 6, press enter, and it'll tell you if that's true. I mean, they're practically giving you the answer. My goodness. It's going to say true or false. Alright, which table does not show y as a function of x? Well, we know functions. If it's a function, That means every x has to have only one y. So we're basically looking for repeating x's. Repeating x's. So do I have any repeating x's here? Nope. So what's the table does not show y as a function of x? All these should be functions but one of them. So do I have any repeating x's here? Nope. Nope. Repeating x's here. Nope. It's almost repeating, but the negative and positive. I wonder what's going on with J. That's a poorly circled problem. So it looks like we do have a repeating x, and the problem with the repeating x, they can repeat, but they have to have the same y. This one has two different y's. You can't have one input and get two different outputs. You can't push a button on the soda machine and get one soda and then push that same button and get a different type of soda. Not only would that be frustrating, but it just wouldn't make sense. So let's go to the next one. Pretty simple. This looks like an exponential problem, doesn't it? Look at the answer choices. Anytime the x is up there. All right, let's solve it. What do they want from us? What do you want from us? In Austin, the use of landlines has been declining at a rate of 35% every year. There are 84,000 landlines this year. Which function can be used? Oh, we don't actually have to work it. Cool. So, but a lot of people are going to make a mistake here, and you probably did this too, and I'm glad you're getting it at your system now. But remember, when we're making our exponential equation, I told you it looked like this. This is our initial right here, and this is our rate. This is our time. But we can expand that a little bit more. But our b we can expand. We can say that's 1 plus or minus some rate to x. So we're going to say plus if it's growing, minus if it's declining, or what do you call that? Decaying. And which one is this one? Well, they say declining, so we know it's going down. So we're going to do our initial, which is 84,000, and then 1 minus, what is the rate? 0.35. That is declining. Well, we don't have any 1 minus anything down here, do we? So what they did is they combined this. What is 1 minus 0.35? Well, 1 minus 0.35 is actually 0.65. So that's the one we want there. And this is the one most people are going to pick because they're going to see, 35, 35. But what that one's telling us is that this one is only keeping 35%, but this one's keeping 65%. Why? Because it's declining 35%. That's the part that's losing, but the part that is keeping is 65. Down here, you're declining a lot faster. You're declining by 65%. So yes, I bet a lot of people missed that one because of that, because you have to actually think. What are they talking about there? All right. What is the equation of the line that passes through the point here and has an undefined slope? Okay, really easy. If, one, you understand undefined slope. Let me draw the picture again. Remember the face guy? Positive, negative, undefined, that's his nose, and 0. So undefined must look like this. So if I have a graph, let's get a different color, kind of tired of that color. If I have a graph and I have a point in that graph that's in negative 11, 15, negative 11, 15. It has an undefined slope, so I know exactly what it's going to look like. It's going to go straight like this, because look at my undefined nose. Well, what is the equation of that line? Well, I told you every point on this line is going to tell you the equation. If it's straight up and down or straight across, you can just look at every point. It's going to tell you. Well, all my x values are going to be negative 11. So I know that's my answer there. So they're testing you on to see if you know what undefined slope is and how to write it as an equation. So those are 2 questions already. we came across like that. And there you go. G. Which expression is a factor of that number here? Well, you can just find the factors, because I'm trying to think of a better way. Why did I do that? There we go. So the obvious way is to just factor this out, but a lot of us don't like factor, and these are kind of tough if you don't know how to factor. But I'm just going to go ahead and factor it anyway, because we still need to learn that skill. Actually, I just had to do this on my test. So I know that the top number goes up here, 24x squared, and the bottom number goes here. And I'm looking for the numbers up here, the factors. I need to find these two numbers to give me 7. So that's going to be 24 times negative 5. 24 times negative 5 is negative 120. And down below is 7. So what two numbers give me, multiply to give me 120 and divide to give me 7? Thanks to a student showing me this little trick, I guess you would say. The calculator can give you all the factors of 120. If you go to the graph and you do 120, let's say negative 120 since we're dealing with a negative. Negative 120 divided by x, and we press enter. We pull up the table for it, and look and behold, you're going to get given 1 times 120, 2 times, all these are factors of 120. I'm looking for one that can give me a 7. So it's easier than counting each one. I could actually just kind of glance and see which one can add or subtract to give me a 7. And there I see one right here. So I'm going to use 8 and 15. But instead of their negative 15, I'm going to make the 8 negative. So I can add them together and get a positive 7. So now I have a negative 8x and a positive 15. Last step is, let's get a purple. Last step is take out the greatest common factor. The calculator does that for you too. The greatest common factor between negative 8 and negative 5, well, the last one's a number's a negative up here. So we're going to do a negative, and they only have a 1 in common. And to show you that, I'm actually going to use the calculator ability to find that. I'm going to clear everything else first. Why do I keep doing that? Alright, so I'm going to go to, I believe it's number, greatest common divisor, and I'm going to type those numbers in. Between negative 8 and 5. Negative 8 and comma negative 5. Press enter, and I told you it was 1. Only reason I put negative 1 is because that number right here at the top is negative, so I know it's going to carry that negative with it. What about 24 and 15? So let's do the same thing. Down here, this time we're going to do 24 and 15. And they're both positive. And that won't really change a whole lot anyway. 3. Now, I'm not going to keep doing that. I'm going to let you do that because I already know. And it's just kind of wasting my time. This is supposed to be an x here, so I can take out a 3x. Over here, is going to be a 3x. No, it's not. It's going to be 2x. Because 2 times 4 is 8 and 2 times 12 is 24. Now over here is going to be a 3. So my factors are here. 2x plus 3, 3x minus 1. 2x plus 3, don't have 3x minus 1. We do have that one. And there you go. That's how we do it. This is how we do it. All right, where's the 0? Yay, thanks for giving me an extra bonus break. Asking me such a simple question. It's right there. Anywhere it crosses the x-axis. Don't mistake it and put here, please. It is right here. At a 1, 2, 3, 4, 5, 6. At a 6. So that's what you'll bubble into your grid, to your griddable choice. And don't be confused by these numbers. This is this point, and this is this point. So don't, some students are going to start choosing numbers because they see it on the paper. I mean, sometimes it's that easy, but just try to think a little bit more. Like, are they really going to give that to you? 6. You can put that in your calculator if you want to, and press enter. I'm not going to do it for the sake of time. You know what? I will, because I already gave you the answer. So if you're watching this, it's probably because you want to know how to get the answer. I'm assuming. So I'm going to go to my graph. I'm going to get a new file. Nope. Graph. And then I want an inequality. So I'm going to delete the equal sign. And I'm going to get y is less than negative 2x. Negative 2x. And that's all they wanted. So I'm going to press enter and voila! How much easier does it need to get? No. Oh no, nothing's even close to the answer. My goodness. So yeah, once you put in your graphing calculator, then you're done. So many ways to solve that, but unnecessary right now. Alright, we have this transformation problem again, and you can do it the same way. Put the original in, then put this in. And just see what happens. So what you're going to see is it starts like this, and because it hippos inside the parentheses, inside the cage, we know that's a horizontal shift, and it's going to do the opposite. So it's going to go where it's not going to go positive 325. It's going to go over here. All right. So again, you can put that in your calculator and look at both of them and see that. And I'll show you that example. So we have x squared, and then we have parentheses x plus 3.25 and squared. There it is. So horizontal shift is not a vertical shift because that's what kangaroos do. They move up and down. Nope, nope. And we're going to go to the left, to the left. Oh man, excuse me. All right, so going to the next problem. This one is really easy, right? Because whenever they say equivalent, you can just put it in your calculator. So you pick this one in your calculator, see what the graph looks like, and put all these others in the calculator, one at a time, and see which one matches. That's really the easiest way. So I almost don't want to work that one because it's so easy, but I will, because it may help one of you out here. Like I said, if you're watching this, you probably need some help with it because that wasn't enough for you. So let's do it. Let's go. First, I'm going to start by putting the original in so I can get a baseline of what it's supposed to look like. Squared minus 23 x plus 7. There you go. That's what it's supposed to look like. And we can just go and start putting all of these in just the way they are. So 2x plus 7 and 3x plus 1. Bam. Nope, that's not it. So I'm going to go back to my equation. And look how easy it is to see that. And I'm just going to go and edit this one. Instead of typing everything, I'm just saving myself some time. 2x minus 7, 3x plus 1. Nope, it's really close though. Really close. But that's not the same equation. Should be so close, right on top, where you can't even tell the difference between the two. So we're going to make 2x minus, we're going to do C right now, 3x minus 7. Bam! Nope, that's not it. I really hope it's D then, because I'm running out of options. 2x minus 7 and 3x minus 1. Oh, see how perfectly it fits? There's nothing like hanging off or close to it. It's undeniably D. And that's it. All right, a private ship carries two types of cargo: large crates and extra large crates. Each type of crate weighs a specific amount. One side of the ship carried 500 large crates and 275 extra large crates, weighing a total of 18,800 tons. One side of the ship carried 190 large crates and 55 extra large crates, weighing a total of 16,1 tons. How much does does an extra large crate weigh in tons? Now, many of us may not even know where to start on this. Like, we see a lot of numbers and stuff, but how do you solve that? And you should be thinking, after seeing enough problems like this, that this is a system of equations, wondering what two equations are going to cross together. So now we need to write the equation that accompanies these two paragraphs. So we got 500 crates, carry 500 large crates, 275 large extra crates, weighing a total of 1,800. So I got 400 large crates weighing something per pound. I don't know. I just know I got 400 of them. Plus, I got 275 extra large crates. I'm going to let that represent Y, some number of those crates, or some weight that they have. We don't know what the weight is, weighing 18,800. So we don't know how much the weight is per pound. How much does an extra large, so they're asking us how much is the weight. So for our other equation, we're going to use this information. We have 190 large crates plus 355 extra large, weighing 16,110. All right, so now that we know we have a system, and that's really the toughest part here, because after this, you can just put in your calculator. I'm going to go to the calculator screen here, delete everything just because I like to. And if I go to menu in algebra, it'll actually ask me, do I want to solve a system? And I'm going to say yep. And I'm going to use X and Y because I stay consistent. My X's were my large, my Y's were my extra large. So 275Y. And then the same thing, 190X plus 355Y. Oh. And press enter. Bam! So now I know that my large is 25 tons and my extra large is 32. And we want to know about extra 2, so we're going to pick G. Let's move on. There you go. Let me pause it here. Alright, let's look at 31. A projectile is launched into the air from the ground. The table shows the height of the projectile at different times. Based on the table, which function can be used to model the situation? What do we do on this? How do we get an equation from a whole lot of points on the table? I hope you're thinking what I'm thinking, because it's so much easier. Let's open up a new file here. To go to list and spreadsheets, right? And just put all these points in here and ask it to give us what we're looking for. So I'm going to put all these in here, 25, 30, and 5502, 5760, 540, 0.5, 43, 40. Hopefully I got those right. Correct me if I'm wrong. Okay, I didn't hear anything, so it must be right. Yep, let's go with that. So now I'm going to look for the quick graph. Let's plot this real quick. X. And yep, there it is. It looks like a quadratic, which is making sense because they're all square. Let's go ahead and analyze it so we can get what that line is. Quadratic, not a line. This looks like a quadratic. Bam, there it is. What does it say? Yep, negative 4.9x squared. 125x, 5,000. This is just too easy. Okay, so it's not this one. Negative 4, it's not that one. So here's our only answer. So if you put the points in right and do the clicks like I just showed you, shouldn't have any problems there. Bam. Which value of x makes the equation true? You can solve this by distributing or just put it in InSolve. Now I actually had one student put this in a graph just like this, doing a relation, and here's what it gave him. It gave him a straight line, and I don't know if it was this problem, but it was a straight line up and down. And what that was saying is that this was the equation of x equals 51, negative 51, and that was the answer. That means that all the x's for this whole thing was negative 51. Now it's not for this problem, but I'm just saying as an example, you could put that whole thing in as a graph under relation and do it, but it's just easier just to use the InSolve feature here because we're solving for one variable. I mean, it's made to do that, so that's what I would do. That's what I'm going to do. Let's get rid of this, and let's just go get a calculator. All right, I'm just going to type all this stuff in just the way it is. First, I'm going to pull up my InSolve calculator. Solve. Yours could probably say numerical solve, but mine just says solve. 1.25. Parentheses x plus 17 there. I finished typing most of it just to save a little time there. Don't forget on the end to press comma x. Okay, then you close the parentheses and it should look like this. If I press enter, it'll give me my answer, which is negative 41. That's all, folks. It's that simple. And you keep hearing me say it's that simple, and I hope you believe in me as you see what we're doing. It's not that complicated. The hardest part is understanding what the question is asking and how am I going to set this up. Once you get past that, like, okay, they're asking for a system of equations. Oh, yeah, I could put two lines in the graph, or use solve for systems in the calculator. Or they're asking me to solve for x, and like this problem, I'm going to use InSolve. You can do all these things by hand, sure. Matter of fact, as I mentioned to you before, you can do them by hand. I prefer you to. But if they give you a calculator, you use the features there to do those. All right. Which quadratic function in vertex form can be represented by the graph that has a vertex at -5, -8 and passes through the point 116? Now, what are they asking? What do they want me to do? So, which one of these functions has in vertex form can be represented by the graph that has a vertex at -5, -8? Oh my goodness, so easy. Just put all the graphs in the calculator and look for a vertex of -5, -8. Remember what a vertex is. Vertex is the highest point on the graph, or it could be the lowest point on the graph. Don't just think because it's negative it's the lowest point. Just put it in the calculator. Now, if you understand vertex form, you already know that this is our h and this is our k. And vertex is given by h, comma k. So now I can look here and find where my h and k is. This is a 5. This is a vertex at 5, -8. This is a vertex at -5, -8. Because it changed it to a plus. This is a vertex at 5, -8. And this is a vertex at -5, -8. So I want a vertex at -5, -8. That can be it. And this can't be it. So which one is it? Oh, they gave us some more information, didn't they? They said it also has to pass through point 116. In other words, my x value, when my x value is 1, I should be getting a y value of 16. So which one makes that true? Well, you could plug it in there with your hand, or again, put it in the calculator and just evaluate it. So I know it's one, either B or D, and I don't have to go through all the choices now. And do I want to do this by hand? I need to show you in the calculator anyway, so let's just go to the calculator. If you get comfortable with this thing, it's so beautiful. All right, so let's go to our graph. We're going to put in one of these equations. I know it's between B and D. So y equals, see, I'm not even going to change it. I can leave it just like that, because we can analyze it a lot better when it's already in y equals form. So I'm going to put in -2/3 x parentheses x plus 5 parentheses x plus 5 squared. Thanks for catching that. Squared minus 8. Make sure I put it in there right. Looks good. Bam. Oh no, where is it at? Oh, well, -5/8 is pretty far down. So maybe it's not in my sight, or maybe I did it wrong. But let's zoom fit. Oh, there it is. It was just right below where I could see it. We was looking over here. So -5/8 happens to be a maximum. I told you sometimes a negative don't mean it's a minimum there. But this is a maximum right there. You could find out by analyzing it and looking for maximum and going to the top over here and going to the left and right. And you see, now we know it's -5/8. So that's why I'm glad I'm showing you the calculator so you can see how to use these features. I'll do it again. Menu, analyze graph, maximum, and then go to the left and the right of that maximum up there, and you'll get it. But we're curious at what is the value of y when x is 1. So I'm going to trace it. Graph trace, and I'm going to either go to 1 like this. See, I'm looking down here at these numbers. It kind of skips over 1, but I can get an idea that it looks like it's going to be about a -16, but that's not what I want. So this is probably not it. But you can find out for sure by just simply pressing the button 1. And now we know that at 1 is going to be a -32. This can't be it. So now I know for sure it's going to be D, because it can't be anything else. I'm going to go ahead and make sure by changing my equation. So we got not -2/3, we just got 2/3. And we're going to press enter this time. And now let's look at it. Let's trace it. And I'm sorry, graph trace. And look for, just type 1. And now say +16, which is what we wanted. So now we know our answer is D. So just playing around with the graph here, and I do mean playing around because it's kind of fun when you're working using the calculator. So, all right, let's pick up on 34. This one's asking us which inequality best represents this piece here. So let me get out my pen. All right, so if we're looking at this, they didn't ask, okay, range. I was like, which one are they asking us for? So what's the range? Remember, our ranges are possible y's, so the highest it can go, well, what is this point right here anyway? So it looks like this at 10 for the x value, 10, and 1, 2, 3, 4, 5, 6, I'm guessing. 1, 2, 3, 4, 5, 6. So that's at 10, -6. And here is at 0, -10. 0, -10. So the lowest y value is a -10. So that's the y, right? And the highest is a -6. So we can be all the y's in between that. So it has to be greater than, equal to -10. That's why it's circled in like that. And the open circle is, it can be less than, but not necessarily equal to. It can be equal to there. So I'm looking for that. These x's don't even count because we're asking for range. I'm looking for g of x, which is representing my y. And the only thing that's different here, as you can see, is the signs. They want to see if you understand the difference between equal and just equal. So we obviously do. So we're going to circle H on that one. Very good. Moving on. All right, which statement about the graph of y equals 1/2 5 to the x is true? If you don't know this by looking at it, and you may not, of course, just graph it. So that's what we're going to do. Let's go to our graph and graph it. So y equals, and I'm not going to put it in standard form, relation. I'm just going to leave it this way. Like I said, if it's already in y equals something. So we're going to put 1/2 5 to the x power. So there you go. Now I can see, looking at this graph, and I knew it would be an asymptote somewhere. So I can see there's an asymptote right here. So it looks like it's touching the x-axis, but it's not. There's actually a y equals 0 asymptote right here. And I know that because this is an exponential graph. Matter of fact, you could trace it. Like if you forgot and you were wondering if it's ever going to touch, you can trace it and remind yourself pretty quickly. So if you went to trace and then moved it over and looked at the value down here, notice how it keeps getting smaller and smaller and smaller and smaller. And you would have thought it touched 0 by now, but you can see that it hasn't. And it still hasn't got to 0. It's getting, this -10 means it's a really small number, but still never touching 0. So let's see what their options are. The graph has a horizontal asymptote. Let's move this back over so we can see. Horizontal asymptote. What a horizontal asymptote means, it's a line going up like this. It's approaching. Now it kind of looks like it, but actually this line is going to keep moving this way and cross that. So no, not a horizontal. The graph crosses the y-axis at 0, 5. Does it? No, 5 is up here. So nope. There's an asymptote at 1/2. As we just saw, it went less than 1/2. It went all the way down to 0.00000. So no, that's not right. And the graph decreases from left to right. This graph is increasing. So I must have did something wrong. So because this is not decreasing. So which one is right? Asymptote at 1/2. No. Y-axis is 0, 5. 1/2 times 5 to the x. No. Horizontal asymptote. Oh. I messed that up, didn't I? Because when they said horizontal, I thought vertical, and you were probably telling me that too. This is vertical asymptote. Of course there's a horizontal asymptote. I just said there was right here. So I should have said A. And they didn't ask us what it was, but it should be y equals 0 if they were asking. So sorry about that. That happens, and that just happened. All right, next one. Table represents some points on linear graph. Which equation represents the same? All right, so same situation here. The only thing different is they're asking for it in point slope form. I wouldn't worry about that. One of the things you can do is you can plug in an x and y in here and see which one is true. That takes too long. I'm going to still put this whole thing into my calculator to find out which one of these gives me the right equation. And I'd rather look at it that way. So let's look at it and I'll show you what I'm talking about. And I would encourage you to do this with me, especially if you got this wrong, so that you can get the feel of it, because you really don't remember until you do it. I just took a test, and I've taken a lot of tests at this point in my life, and I've read a lot of studies. And it's hands down, you have to do it. Sitting and watching someone do it absolutely is not the same thing. You don't learn as well that way. So you want to do this first, pause it, try to work it, go as far as you can. If you get stuck, then you watch the rest, or just to watch to see if you did it right. But don't just be consuming like a consumer watching what I'm doing. Alright, so I put these all in. Now I'm going to get a graph. The new way I like to do it is go Data and Quick Graph. Click on here for my Y and then my X, and you can see it's kind of turning here. And oh wait, it's not turning, it's straight. So I was going to say it's turning because I thought it was a squares, but no, it's a straight line. So we're going to analyze this as a straight line. And there we go. This whole thing here. Now the downside about putting it all in this little space is you can't see the long equation when you want to, but that's okay, we can move it around. So it looks like it's going to be a slope of 1/3 x. So with that in mind, I can go ahead and cross out a couple of them. So I know it's not going to be a 3x. So now my only question is it the f or g? It's not h or j, is it f or g? So I could, what's the easiest way I can do this? You could take one of these points, 10, and see if you get 121. One of the ways I would do it, just because I'm used to it, is I would go ahead and solve for y. I would add 16 on both sides and add 123 on both sides. You can distribute these, but I know a lot of us want a different way to work it, or at least a different way to check it. So probably I will put this in relation, okay? So that's what we talked about before. That's one way we could do it. So I go back to my graph, and let's get a new file. And I will put this in relation. Go down here. And we know it's f or g, so let's just put one in. So we're going to do y minus 16. And the answer should be pretty obvious when we trace it. So 1/3 x minus 123. And make sure I put that in right. I think so. And there it goes. Nowhere to be found. Now the tough thing about relation, like I told you before, is it is tough to find because it won't really connect with the rest of these tools. I'm going to see if I can find it with zoom. Oh good, so at least found it. I should have put trace. Let's trace this graph. And what I'm looking for is when x is 10, do I really get 121? So I'm going to type in here 10. And I get negative 21. So I know this is not the right answer. And I can already tell you it's going to be G. But what if I made a mistake like I did in that last problem? So let's just double check it to be sure. Go back up and change this to 123. Let's see, did we put that in right? Looks good. Alright, so let's go, or let's just trace it this time. So it's going to take us there. See if we start moving it around, it'll take us there. I want to know where 10 is, and there it is, 121. So now I know it's this equation, and I'm good to go. So it should be G. And there we go. Alright, what's the solution to this? I'm hoping you are thinking you know what to do on here. I'm hoping you got this one right, or at least know what to do now. You can just use insolve. If you want to graph this whole thing, great. It'll be a vertical line going through the x value, that's correct. But I will use insolve. So I'm going to put this in my insolve here. I'll go to menu, algebra, and yours should probably say insolve or numerical solve, and just put in just like it says here. I typed everything in insolve. I made sure I put comma x at the end so it can solve for x, and I press enter. X equals 6. Can't get much easier than that. And there you go. Alright, so next problem. A parking garage charges $10 interest fee plus $4 each hour. $4 charges $10 interest fee. So I'm looking for a graph that starts at 10 and a rate of $4 an hour. So anytime they say something per hour or per mile, whatever it is, you know that's your rate. So $4 an hour, 10,000 injury-free cars can park in a maximum of 24 consecutive hours. So you better not go over 24. Nobody went over 24, so great. Don't really need that information then. But I do need this. We started at 10. That didn't start at 10, so that can't be right. This is starting at 20 something. This is 10 and this is 10. That's just dumb. I'm sorry, but these problems are so ridiculously easy. If you have half a clue if you're just halfway reading a problem, you can do very well in this test because they really don't challenge you too much. So there's 10 and there's 10. Now we just need to find a rate of 4 that's going up $4 per hour. So let's get another point. So here's a point here. This point is for right in the middle of 20 and 40, so that's 4 and 30. And the original point here, it's not the original, but the initial, was at 0, 10. And this point here is, I guess there's one there. Gotta go way up there to really see a good point. And this again is at 0, 10, as we just shared earlier, but we have a point here at 20, 90, I guess that is. So the question is, which one of these have a slope of $4? You can put these 2 points in your calculator and find that slope in the equation, or you can just count. You can just say how much did I go up and over by. So I know I went from 10 to 30, so that's up 3. That's my change in y. And then from 0 to 4, that's 4. So this is not $4. I went from 10 to 90, that's $80 we went up. And from 0 to 20, that's $20. Well, if I reduce 80 and 20, divide by 10, the zeros go away. 80 divided by 2 is 4, so there's my $4 for every 1 hour. So now I know my answer is J. Alright, which expression is equivalent? You just kind of remember your rules on this one. The 5 goes for both the 2 and the x squared. The negative 1/3 goes for the 9. So we're going to say 2 to the 5th is 2 times 2 times 2 is 2. A lot of people are going to say 2 times 5 and mess that up and get 10, but no, it's 2 times 2 times 2 times 2 times 2, not 2 plus 2 plus 2 plus 2. That's wrong. So please don't make that mistake, because by just knowing that, we can cancel out half our answers. We know it's not going to be 2 times 5, it's going to be 2 to the 5th. All right, so the next challenge becomes, let's erase this. We got 32, so I got the 2. And 2 times 5 is x to the 10, so I'm going to multiply those. And 9 times 1/3 is x to the 3rd. Since I have like bases, I can add my exponent, so 32 x to the 13. Bam! Again, if you had 50-50, you could have guessed there. But of course, let's go ahead and get the right answer. All right. The function here can be used to determine the cost in dollars of a tax rate and X amounts. What is the rate of change? That's kind of easy, because rate of change is always, look, if you look at mx plus b, it's always going to be here, your slope or your rate. So I know I can distribute here and get 1.75x. And even if I did it here too, that's just going to give me a number, 1.75. And if I added this to it, it's still going to just give me some number like 6, 7, or whatever it is. But here's what's not going to change. The number in here, which is my m, is going to be my rate of change. So please pick that for your rate of change. A lot of people missed this one, surprisingly, when I showed you at first. So hopefully we got it right this time. It's going to be h. Alright, which expression is equivalent to this? Again, you can put all these in your calculator. I mean, if you know how to factor, go ahead and do it. But if you just want to use your calculator, you can. So if you do know how to factor, you can just put these in here and start your factoring. Two numbers that give you negative 28. Add up to 12. 7 and 4. Will that work? 7 and 10. Is that 7, 8, 9, 10, 11? That's 11. So that's not going to work. So 8 and 3. No, that's not 28. 1, 2, 3, 4, 5, 6, 7. Am I missing something? I feel like, all right, let's just do it in the calculator. All right, so if I couldn't figure it out like I'm doing now, and maybe you couldn't, you could actually figure this out in the calculator using the method I shared earlier, where we can find all the factors. So I'll take that negative 28 divided by x, and I will look for the table. Don't worry about the graph. But if we looked at the table, it'll give us all the numbers we need. So I can see that 1 times negative 28 is 28, 2 times negative 14 is 28. Which one of these would give me a 12? So 7, 8, 9, 10, 11. That's not going to do it. Nope. 7 and 4 is not going to do it. So I'm looking for whole numbers. That's why I keep moving. Oh, 14 and 2. Great. It's pretty simple. So 14 and 2. And I need a negative 2. So since this is a 1, this becomes really easy. Those are my factors there. So x plus 4, x minus 2, x plus 14, and x minus 2. So it's going to be this one. Now, if you didn't understand how to get that, do what I've told you before and just put them in the calculator. Let me erase this and show you what I mean. So if I went to my calculator, I would just put this whole expression in there. Of course, I'm not going to write r. I'm going to use x squared plus 12x minus 28. And I'm just going to start putting, and it doesn't matter that you can't see the whole thing, just enough of it. I mean, if you want to, you can. Let's fit it. So that's a little bit more of it, but it's not that important. And don't try to get the 0, right? Don't try to put a 2 there. Yeah, you guess you can if you know what you're doing. You can say, I know it's going to be a 2, so it's going to be r minus 2, and I know it's going to be a negative 14, so it's r plus 14. But if you still don't really get that, just put all these in the calculator and see which one matches. I'm probably not going to do all these, but I want to do enough where you can get it. So x minus 7 and x plus 14. So I'm going to press enter, and obviously that graph is off, and we already know the answer. So, but if I went through all of these, you'll see none of them going to match. But if I did the last one, x minus 2, and again, notice I'm using x instead of r because the calculator is not going to recognize r. And x plus 14. So x minus 2, x plus 14. And you can see those are perfect graphs for a reason. Now, I know for sure without a shadow of a doubt that's correct because they perfectly match. So that's what we're looking for. All right. 41, and we're going to 42. I really doubt you get a question like this on causation. Which one? Causation means they have a relationship by which one thing causes the other to happen. So there's a cause and effect relationship. And let's see if I can get this right. When the water bill increases, the electric bill increases. That's not true. The electric bill is not affected by the water bill. So I should know that, right? Doesn't make sense. When the number of reports of flu increases, the average body temperature increases. The average body temperature? That kind of makes sense because when you get the flu, yeah, the average body temperatures in some part of the world may be increasing because the number of reports of flu is increased. So I'm gonna keep this as a possibility. When the water level in the reservoir decreases, the amount of rainfall the water level in a reservoir does not affect rainfall. That'd be crazy. Like the rain notices the water going down, so it starts raining. No, that's not going to work. when the amount of exercise increases, the amount of calories burned increases. That's true, and those are correlated. When the amount of exercise increases, the amount of calories burned increase. So I didn't like B before, and sometimes this can happen, right? You have two possible choices, but now I know after reading D, it's probably going to be D. Let's check and see. Yep. So I didn't like B anyway. But moving on. All right, which one of these makes this graph? You already know what to do here, right? So which is equivalent? Just put all the graphs in there and see which one matches that one. They're hoping that you know what a quadratic looks like from looking at this setup. But if you don't worry about it. Just put it in the calculator. So for instance, for me, I know that this is in vertex form, and that this negative make it open down like this is doing. So there's a vertex at -3, 8. So is this 1, 2, 3, and there is 8. So I know that this might be it, and it's been shifted to the left 3 units. Remember, this is a hippo. So 1, 2, 3. Yep, shifted to the left. That's probably the right answer, just looking at the first one. But again, you can just put all of them in there in the calculator and see which one matches. I don't want to spend time doing that. I think that is clear. It makes sense. Let's see what the answer is. If I guessed it correctly just looking at the first one. Nope, I didn't. So I'm glad I didn't do that. So let me put it in the calculator, since I got it wrong just from trying to guess. And I don't want you to do that. So if I were to let's put that first one in the calculator and see why did that not come out. It was looking pretty good for my explanation. Squared plus 8. Okay, see, now it becomes pretty clear, right? I need to delete this one. All right, so now it looks pretty clear that this does not look like that. Matter of fact, let me change my zoom again to standard so I can see it better. See, theirs goes up to 10, so I might want to change my Windows settings to match theirs. If you wanted to do that, you could do, I think it's here. I forget how to change those settings. Yeah, here we go. So you can right click on the screen and go to Windows settings, and you can change it so that your axis right here is from -10, which is what it is already, so I'm going to leave that alone. But I can change my Y so that it's the minimum of -10 and the maximum of 10, just like they have it. So they have a minimum down here, -10, and maximum 10. And they're counting by 1. So if I want to scale it, I can count by 1s also. So it can look just like theirs. There we go. So, hey, that looks pretty close. Now I'm thinking about it. I don't feel too bad for getting that wrong. But I can see this 0 right here. 1, 2, 3, 4, 5, 6, 7. There's a 0 at -7. 1, 2, 3, 4, 5, 6, 7. And it's clearly not here. So that's a giveaway. And there's another 0 at 1, and there's not one here. So, man, that was really close, but obviously not right. Now if we put this one in, which we know is the right answer, it should give us that equation. So let's do it. -1/2 x squared minus 3x plus 7 over 2. Alright, so now we can see it has a y-intercept, I'm sorry, x-intercept, or a 0 at 1 and 1, 2, 3, 4, 5, 6, 7. 1 and 7. So now we know that's right. And we could even count up to the vertex, and you can let the calculator do all this for you too. You know, find your zeros, bam. Your other 0. Click on both sides and find the max. So, and just compare it to what you have here, and all these points do match, and the other ones obviously won't. That's why that's the right answer. Table shows the heights. What's the correlation coefficient for the data indicated about the strength? Man, this is not a fun question. And let me go ahead and put this in, because there's probably one question, maybe one question you get on this, but I at least want you to have a fighting chance at getting it right. So I'm going to go ahead and work this. So I'm going to put these in my, actually, you know what? I'm going to title this, instead of X and Y, I'm going to title it height and length, because it doesn't matter which one it is for this one. No, I don't want all that right there. And you can still work it the same way. So I got 15, 16, 23, 25, 25. So this will look weird at first because you're not used to seeing ones that aren't X and Y, and you got these numbers in crazy orders. So this is a scatter plot we're making, and we're going to ask it to draw a best fit line and see if that line is a weak positive correlation, strong positive correlation, and all this stuff right here. So let's look at it. This time I'm going to bang out so I can see the graph bigger. So we're going to call the height our X and this our length. And look at this craziness here. So I don't even see anything, but we do want to do a line here because we're going to see how close these dots are to the line. All right, there we go. It's obviously negative, so because it's negative, I can go ahead and cancel out probably two of them. So it's not positive, not positive. Is it weak, negative, or strong? Well, that depends on how close the dots are to the line. So these dots aren't that close. So I will go with a weak correlation that's negative. Let's see if that will be the correct answer here. Strong. Oh my. Okay, so weak. For the STAAR, for their weak, see this, to me this would have been weak because I'm used to seeing a lot of points a lot closer, but for them this is strong, so I'm guessing their weak will be like way out here. So keep that in mind. Plus I believe this number, this negative 0.3, if it were closer to negative 1, it may have been considered stronger. Yeah, I believe that's correct. So, well, just keep that in mind. So I'm glad we went over that. All right, the value of y is directly proportional to the value of y. If something's directly proportional, if you remember proportion, it has to have, it's going to go through the origin. So it's going to be some number times x. 3x, 4x, $10 an hour, $4 an hour, whatever it is. So you just need to know this if they ask for a directly proportional problem. If y is 21, so now we got that set up, we can easily do this. If y is 21 and x is 126, well, now we know that we can figure out what k is. So if y was 21 and k was 126, let's figure out what k would be. Because they're about to ask us, well, what's the case when x is 45? So let's do that in our calculator. And I could divide both sides by 21 for that. So 126 divided by 21, it gives me 6. So now I know my k is 6. That's the rate that we're working with. And when they ask me this next question, I can say, oh, instead of x here, I'm going to put 45. And instead of k, I'm going to put 6. So 6 times 4 is the same thing as 3 times 90, which is 270. But I'll work it out in the calculator so you can see it. 6 times 45 is 270. So that'll be my answer for this one, 270. Oh, that one went too fast. What? Oh my goodness. Man, I am missing these problems. Okay, look. Let me show you why I got that wrong, because I went too fast. So y equals 6 times y equals, oh, because I did it backwards. I did this twice actually. I did it wrong twice. All right, so y equals kx. Y is 21. K we don't know, and we got 126. What I did wrong is divided by 21 when I should have divided by 126. See, we normally divide by that smaller number, so I just quickly did that because I'm doing this late and I guess I'm making more mistakes. But 126 divided by 126 is k equals 21 divided by 126. That's what should have been over here, and what I'm going to put in now. 21 divided by 126, and that's 1 over 6, not 6. Now I have that, I can put it back into this equation. So when x is 45, k is 1 over 6, and we got 45 here. And now when we do 45 times times 1 over 6. That's how we're getting that 7.5. All right, let's go to the next one. Half-life of a radioactive element is 1 hour. Which function can be used to find the amount remaining after x hours if there is currently 48 grams of the element? So currently there's 48 grams, and the half-life is every hour. So every hour. So we're starting out with 48. Nope and no. So this one here is telling me that we're doubling, but half-life means we're cutting something in half. So that's the one I'm going to pick there is A. So that becomes pretty simple if you know what you're looking for in exponential. So your initial is always in the beginning, your rate is right next to it. What's the slope of this? You could solve it for y. You know, subtract 3x on both sides. Negative 10y equals negative 3x plus 40. Divide by negative 10. Y equals, and the reason we would do this is so we can see this part here in slope-intercept form. So negative 3 divided by negative 10 is negative, just positive 3/10 x. 4 divided by negative 10 is negative 4. There is my equation. Same equation, just in slope-intercept form. Now I know it's going to be 3/10. But if you didn't know that, what could you do? You could just use the calculator. I would have put it in the relation form and just looked at it and counted the slope from there. So you could just put it in relation form. Go 3x minus 10 y equals 40. So I know it's going up, so I can cancel that one out, and I just get 2 points to figure out how fast it's going up. And those 2 points can come from you just tracing the graph. So I can go trace this and get any 2 points I want. 0, negative 4 is a great one. Well, x and y intercepts are always great because they have a 0, which is easy to calculate. So I'm starting from 0, 4, and let's say we're moving over. So we're moving all up. And I love to find the x-intercept because, like I said, it's much easier to count. Let's see if they'll let me get it. There we go. So there's a 0. So you can just count from here. Well, I know there was a negative 4 here, so I went up 4 and over, what was that number there? 13.3. So 4 over 13.3333. This can be reduced. The closest is going to be here. So if you found a decimal of this, it'll be pretty close to the same decimal as here. Because this is better represented as a fraction, 13 1/3, which is the same thing as 39, 40 over 3. but that's not this one. So 30, 40, yeah, 4. Okay, yeah, 4 divided by, it'll be 4 divided by 40 over 3. Man, this gets ugly. So you have to divide 4 divided by 40 over 3. Hey, let's just get another point, or yeah, probably get another friendlier point that's not a decimal. It'll be easier to get to this. Or just look at them both as a decimal. So you do 4 divided by 4 over 4 over 40 over 3. Man, that is just too nasty of a problem. But it should give you pretty close to the same decimal for each one. And let's show our answer. So we already knew that. All right, expression, what is the value of n? So if x to what? What is this going to give me? X to what? Well, when we multiply like bases, which is what's going on here, what can we do with the exponents? So hopefully you're saying out loud to yourself, we're going to add them. Negative 23 plus 5, negative 18. X to the negative 18. So what is n going to be? You want to say negative 18 here. Check that. And there we go. Alright, which inequality best represents the range of this one? The range is as how far up and down, right, on my y. So what's the lowest this line's going to go? And you just want to ask yourself those questions, because when I ask it for a lot of students, it's easier to answer if I just ask what's the lowest and what's the highest. So it's going to go on forever up, but it can't go on forever down. So it looks like that's 10,000 or 12,500. So I'm going to go with everything greater than 12,000. It's not all real numbers because it doesn't go down forever. And it's not x because I'm not even looking for x. And it's not in between 12 and 50 because it doesn't stop. So my answer becomes easy. Easier. And there it is. Alright, secrets can be generated by using this, where A1 is 8, n is a whole number. A1, that's the first one in the term. How do you get the second one? Well, they're telling you right here. This whole thing is saying take the number you just got, which was 8, and multiply it by 6. So that's 48. How do you get the next number? Well, take the number you just got. So say for instance we're looking for the third place right here. They say 3 minus 1 is 2. So take whatever your value was in your 2 position, in your second position, and multiply by 6. And it's going to keep on going on. But it looks like we're not going to have to go that far, because nope, it's not 16, not 14. Could be 48. Well, if we moved over one more time, we could figure it out. So if we just said 6 times, and we can already see that because 8 times 6 is 48. 8 is the last number. This is the only one that has an 8 on the end. So I'm already knowing what the answer is. But I'm going to put in the calculator so you can see it. I can make a believer out of you. So we're going to do 48 times 8. I think that, yeah, 6. And there's our 288. Alright, let's continue here. A local cookie company sells cookies in a variety of flavor. A teacher is ordering cookies for the school graduation party and wants a combination of chocolate chip and sugar cookies. She does not want to spend more than $200 if chocolate chip cookies. That's a lot of money on some cookies. She really likes cookies. I wonder what she looks like. It's a lot of cookies, unless she's giving them away. If chocolate chip cookies cost 75 cents each and sugar cookies cost 60 cents each, which inequality represents all combination of X chocolate chip cookies and Y sugar cookies? So we know we can't spend more than. Can we spend equal to? Yeah, we can spend equal to $200. Can we spend more than? No. Can we spend less than? Yeah, as long as you don't spend more than that. All right, so which one is saying? This is saying all this can be less than or equal to. And that's what we want. We want it to be less than or equal to. So I like that. This says just less than, but it can be less than or equal to, since it didn't restrict it. So this is not going to work. Less than equal to, this will work, and this is greater than, it won't work. So all I have left is A and C. Now we just have to match up to 75 with the right letters. So X is the chocolate chips and Y is the sugar cookie. So X, chocolate chips is 75 cents. So 75 cents and X should go together, and 60 and Y. So there we go. Alright, which of these best represent the rate of change of the temperature? I would just get two best points you can. Now they make it hard to find these points because they want to see your estimates. I found a point right there, and I'm going to use this one. That's a long way off, but I want a pretty decent point. So if I drew my slope triangle, how much did I go down? Well, I went 10, 20, 30. So I went down 30. There's my change of Y on top. How much did I go over? Oh goodness, I didn't go down 30 right there. I should have went down 40. I didn't count. So 1, 2, 3, 4. So I went down 40. Notice I didn't say 4. That's a big pet peeve because they're counting by tens on the y-axis and counting by ones on the x-axis. So I count by ones. So I can say this is going to be 9. Looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. So there we go. So what is that as a decimal when you can estimate it? 40 divided by 9. 4.4. Oh, that becomes really easy, doesn't it? There's nothing even close to that. Alright, let's do 2 more. Which graph represents a function with a range of all real numbers greater than or equal to 4? So I'm looking for a 4 like this. 1, 2, 3, 4. It's probably this one because it goes up forever and its lowest is 4. Nope, that's not greater than. This is a y value of 0, and this is a y value of 0. So A looks like the only choice here. So this, you just need to understand what domain and range is and how to correctly identify it. All right, let's do our last one. Yay! A system of equations. If they give you one this simple, I would just graph it and see where they cross, or put it in your tool in the calculator that actually does systems. So if I go to my calculator screen here, looks like I already did one, but let's erase this. But I have this one instead, so we can go menu, algebra, and solve a system of equations. I'm using x and y, and just put both in here. Again, I don't think this is a skill that should be available to you because it compromises what we know and the steps in math. But it's here nonetheless, and we're going to have to maximize it. Oh man, I deleted the other piece. Okay, let's do it again. Y plus 3x equals -1, and y equals let's do 1/4, but it's actually a -1/4, isn't it? So I put a negative there, plus 10. And we're really curious at where these two are going to cross. And I put something in wrong because it should have gave me a whole number, and I see what it is. Do you see it? I see it. We got to put an X after the. That's why I always check my work until except for that point. All right, so what is the value of X? Don't make a mistake and put the value of Y, which is waiting for you on F. What's the value of X is -4. Bam. Alright guys, thanks for tuning in. That was pretty long, I know, and hopefully you got some good information of how to use the calculator and some strategies. And hey, the best to you on the test. I'm with you. I put a lot into you. You've worked hard. Let's make the most of it now and shine, celebrating on this test. Alright, till you next time. Talk to you later.